Okay, today we're going to be talking about resistance. And the first thing I want you to think about is what kinds of things might determine the amount of current that we end up with in a circuit. And there's basically two things that are going to matter. One thing is the potential difference, or the battery that is being applied to the circuit. So if you have a larger battery, you're going to have more current. And the other thing that's going to matter is what is actually attached to the circuit. So are you trying to run a hairdryer? Are you trying to run a microwave? Are you trying to run whatever it might be, a light bulb, a higher wattage light bulb, whatever it might be? That's going to affect how much current you're going to get produced in your circuit. So first, we're going to focus on this portion. We're going to focus on how does what is attached itself affect the current. And this is where the term resistance comes into play. So the definition of resistance is it's the impedance. Impedance means to get in the way. If I were to impede your progress, if you're trying to get in the door, I would be standing in the doorway for you. So impedance is just something getting in the way. So it's the impedance of the motion of the electrons through a conductor. So as we've talked about before, electrons don't just have a free path as they're trying to get through that conductor. There are things getting in the way. There's the molecules. Conductors are made of something, if it's copper or aluminum, whatever those molecules are, and they get in the way. They're moving around. So the electrons don't just zip on through. There's stuff keeping them from being able to move nicely. So if we think about electrons trying to move through the wire and thinking about what we talked about with drift velocity, the electrons are going to hit all of these different obstacles that are much larger than they are. A proton is much, much bigger than an electron. So as this little electron is trying to make its way through here, it's going to hit things and bounce back and hit and bounce back. And some substances naturally have more of this going on. Some allow things to move forward more easily. And that idea of how easy or not easy it is for the electrons to get through, that is what we determine or call resistance. So this is just kind of a visual as the electrons are going around through this circuit here. So the electrons are going through. There's places where there's more obstacles than another. Well, if this part is going to sort of slow down, it's going to slow down the current throughout the entire thing. So the more obstacles there are, everybody is going to be affected by that. So there are four factors that can affect the resistance. So specifically thinking about a wire. So think about different things we might change about a wire to make it have more or less resistance. So one of those factors that we could change would be the length of the wire. Well, if I'm trying to get through, like let's say a hallway, if a hallway is really short, that's going to be easier to get through than a really, really, really long hallway. It's the same idea with a wire. Less resistance would be a short wire. So if the wire is short like this, and greater resistance would be with a longer wire. So when you think about electricity having to come all the way from the electric company all the way to our homes, the length of that wire is really, really substantial. And a lot of energy is actually lost through that process. When we're talking about just a cord in our home, that's not such a big deal, but really long wires do require or do cause to have a greater resistance. Another thing that's going to matter about the wire is the cross-sectional area. Another way of saying the cross-sectional area of the wire, if that doesn't make sense to you, is the thickness of the wire. Some of you may be familiar with the term the gauge of the wire. So think about drinking through a straw. If you try to drink through a really skinny straw, like a coffee stirrer, it's going to be really difficult to get that material up. But if you're drinking through something like a big gulp straw that's much wider, it's going to be much easier to get that up. So you're going to have less resistance with a thicker wire. So I'm just going to try to draw your thicker wire here. And then over here, I think I drew these dotted lines backwards, but over here we're going to have a shorter wire or I'm sorry, not a shorter, I meant a thinner wire. Let me make sure it looks thinner here. So much thinner wire is going to require a much greater amount of resistance. Okay, so less resistance is thicker. Think like that big, thick straw. Greater resistance will be a thinner wire. Another thing that's going to matter with the wire is the material itself, because some materials just provide less resistance than others based on their material that they're made up of. Less resistance, the one I want you to know, would be copper. This is why we use copper wiring in our homes, whereas we're not going to be as likely to use something like aluminum wiring, although some homes have used that, but it doesn't have as good of a resistance. It's much higher. So again, you're going to lose a lot of energy because of that, because of all that extra progress. As the electrons hit different things, they lose more energy, and that can be a problem with your energy bill. So we tend to use copper because it has less resistance. The last thing that is going to matter here is the temperature of the wire. Because the wire has all of these collisions inside of it, you're going to have heating of the wire as the electrons go through. So if there's a low temperature, like think about the filament of a light bulb, like a traditional Edison style light bulb that has the filament that glows hot. Well, it's really, really thin. That's why it glows hot, because it has a very, very high resistance. It's difficult for the electrons to get through. So when the temperature is low, it's going to have low resistance. The little molecules inside are not moving as fast, so it's easier for the electrons to get through. When the temperature goes up, the molecules inside are dancing around all over the place, and because they're moving much more quickly, it's much harder for those electrons to make their way through. So in general, a higher temperature is going to result in a higher amount of resistance. So the four factors that affect the resistance specifically of something like a wire are its length, its thickness, the material, and the temperature. So we have things in a circuit that are actually called resistors. And in a circuit, a resistor is a component that's designed to reduce the current. So it is a specific component that's designed to moderate the current, to make sure that the current is the precise value so that there's no damage to that particular substance. There's two different types. There's a variable resistor, which means the resistance can be changed, and then there's fixed, where the resistance is always the same number. So many appliances use resistance to turn electrical energy to heat and light energy. So for instance, this coil here in this kettle, or the same thing that you would see in your like toaster oven, where you see the elements glowing hot, that is happening because it has very high resistance, which makes it get hot, and therefore you can convert that energy into thermal energy, and you can make the water hot, or you can toast your bread, or whatever it is you might want to do. Again, another purpose besides to get maybe heat out of your wire or your device is to control the current in the circuit. Some devices can only have a small amount of current going through them, so resistors can help protect those devices to keep the amount of current going through. So these you may have seen pictures of, or you may have seen inside an electronic device if you have ever taken one apart before. These are resistors. These are the fixed resistor type. And down here at the bottom, you see this little color code. Each of those little stripes refers to a specific number, and electricians would certainly have this memorized. So they can tell what size resistor this is just by looking at the colors. And again, it always has the same amount. And the purpose of this resistor is to ensure that the current going through the wire is the correct amount for that particular device.